turning neutrons into fusion fuel. MIT team wins ARPA-E grant to study fuel generation for future fusion power plants. One of the things that you get good at while at MIT, says Sara Ferry, a research scientist in the Plasma Science and Fusion Center, is being able to start from nothing on a particular system or key and knowing how to approach it in a way that's effective. Ferry has been at MIT for 15 years as an undergrad and doctoral student of nuclear science and engineering, a postdoc, and now a research scientist mostly working on nuclear materials and fusion. But there is a lot of variety within that territory. She's studied general engineering, salt chemistry, corrosion, fission, and fusion, and even pursued a startup along the way. She gestures toward a whiteboard by her computer. It has like 10 different sections for all the projects that my team is working on, and they are all very different from each other. So intellectually, it's very exciting. What she's most excited about at the moment is a $3 million grant that the PSFC just received from the government's Advanced Research Project Agency Energy to study the generation of fuel for fusion power plants. Whereas today's nuclear plants operate on fission, the splitting of atoms, some of tomorrow's plants may run on fusion, the joining of atoms. The most energetically favorable fusion reaction fuses two isotopes of hydrogen, deuterium, and tritium. In deuterium, the lone proton. In hydrogen, nucleus is accompanied by a neutron, and in tritium, there are two neutrons. Deuterium is abundantly found in seawater, but tritium is rare and expensive, so researchers have to harness the neutrons ejected from the fusion plasma to produce more tritium, which can be used to refuel the plant and provide startup fuel for new fusion plants. To make tritium from neutrons, engineers must surround a fusion plant's core with what's called a tritium breeder blanket. The breeding material in blankets contains lithium, which produces tritium when it interacts with the high-energy neutrons originating from the fusion plasma. The goal of